Hello, everyone. I'm really happy to be here. And before I begin, I would like to start with a small warm up. So I want you to do two things for me. First of all, I would like a really great round of applause for all of the organizers of this year's Devfest, please. Let's go. Great. And second, I want a second round of applause for all of you for getting all the way through here. Okay, so what are we going to talk about today? We're going to talk about how we can hide some more sensitive information within our Android applications. And what would be sensitive information? Application data, user data, anything that might be inside our application is pretty much vulnerable. So we're going to try to see how we can hide some of those things. So let me begin. My name is George Kortsaridis. I'm currently working for Amazon in the Ring team. And before that, I was within Amazon with the Fire TV team, working on some applications like the BBC iPlayer, all four which are like major UK public TV providers. So let us begin with exactly what I said before. What actually is there inside our applications to hide? We, of course, want to hide any of our source code. Any of our source code that we're writing, any of our algorithms, all of those things are important. And of course, we don't want them falling into anybody else's hands. We, of course, want to hide any resources that we have. So manifests, strings, values, layouts, drawables, anything that is as a resource for an Android application, of course, needs to be hidden. And then, of course, we also want to hide any extra modules, any libraries that we're using, anything that it's not the app module pretty much also needs to be hidden. So by default, let's say, all of those assets are not safe. They are open, they are not encrypted, they're not anything, and they're there for anybody to just download, decompile, and use. So let us continue with some motivations behind why all of this is happening. Why are we having all this like reverse engineering thing happening? So first and foremost is usually either to steal or leak information. It might be to disrupt some services. So let's say that you have a service that's running frequently and somebody wants to just disrupt this whole smooth operation. It might be driven by purpose. So, you might have heard of hacktivism. That is, that has actually spiked up the last couple of months. And then, of course, is always the usual reason, which is financial gain. Economy is behind everything. So, of course, behind hacking, there are always some financial gains as well. Of course, there's some good ways to try to reverse engineer some applications, and that's why we're trying to opt into. And then, of course, is bug bounty. So there are a lot of big or small companies that are pretty much giving out an open bounty to anyone, saying, hey, hello, if you try to find any sort of vulnerability in our application, any sort of thing that we can fix, and let us know instead of just exploit by yourselves, we can reward you by either money, either a position to work with, or anything pretty much. And then, of course, there are actually security audit companies that are actually getting paid to do exactly that. They have security experts, and they get your service, they get your application, and they try to reverse engineering. They try to find anything that they might think that is important, and then pretty much they, instead of going public, they tell you to it, and then you try to find a way to resolve it. Now, let us continue. Today's agenda. Today, the talk is going to be split in two parts. First, we're going to have the offense part. So we're actually going to decompile an application live. I want to show you how it can be done, and I'm going to show you how easy it is to find a lot of information about an application. And then we're going to switch to defense, and we're going to see how we can actually guard our application, how we can hide some of all of those stuff within our applications a little bit better. So, as I said, we begin with the offense. And before I actually get to decompiling, I would like to go through this algorithm, and I'm going to show you pretty much what's happening when we press build inside Android Studio. What happens when we try to build an Android application? First step is to create the packaged resources. So the packaged resources is pretty much the manifest, all of the resources of your application, all of the assets. All of these things are getting packaged together into the AAPT file, the packaged resources. And then we're doing the same thing for the bytecode. So the bytecode is again the source code that we have written, and any other libraries or third-party modules that we might be using. Again, all of these things are being packaged together into their own bytecode. Then we're getting the packaged resources and the bytecode, bundle them together again, and now we're having an unsigned APK. The unsigned APK cannot go into production, cannot go into the public's hands. So what happens is that we need to have a key. We need to generate a key in order to sign this unsigned APK, comes signed APK. And then that signed APK goes through ADB to your phone, it goes to Play Store, it goes to the public. So the main thing that I want you to focus here, and we're going to talk about more of it later, is the key. The key, out of all of these things that are happening in the background, is the only thing that stays within your reach. It's the only thing that the hacker cannot obtain from the APK. Of course. So I'm gonna speak more about it, but just I want to stress this out, and I want you to know, out of all of these things, the key is the main thing that remains within you. Great. So I'm gonna go to the PC, and we're going to actually decompile live an application. Cool. So I have an application ready. It's called Super Secret Application. And this application actually will give us a task, and we're gonna try to actually figure out that task and pretty much finish with it. So this application has two screens. The first screen, as you can see, has a simple image, some text, and a button. So the button takes us to the next screen, to the next activity, and if we actually read this activity, we can see that it says, below is my secret key, but you cannot see it. So below this text is actually a second line of text. And what we will try to do is we're gonna find out why we cannot see it, and what is its actual value. So let's do that. How are we going to do it? So actually a couple of months ago when I did this talk again, I had to actually download all of those like command line tools like JDK and like APK decompilers, and pretty much it was not as easy, not as straightforward to do. Now I just figured out there's actually some free VS Code add-ons that they can literally do all of the work for you without pretty much like doing anything. It's just drag and drop, just a couple of clicks. And the reason I'm using this way is, again, because I want to show you that it is really simple and really easy for anybody to just obtain your APK, because all of the APKs are pretty much free on the internet. They can download your APK and they can just decompile it. So how we're actually going to do this? I'm going to use the APK lab, and the only thing I'm going to get is just the APK. This is the public production APK that will go to Play Store, that will go to the internet, that will go to the public in general. So I'm going to select the APK, and there are a couple of things, and if you have more time and you're interested, you can just tweak and play around. But what I'm going to do is I'm just going to decompile Java, and I will only check the main classes. And I'm going to leave it for a couple of seconds to do its job. You can see a little bit of details about what's happening at the bottom, and pretty much we are ready. And let us go here. There you go. So that should open automatically, but it's okay. So this is everything that we have managed to Okay, now it opened again. Cool. So this is anything that the decompiler managed to obtain automatically from us. And you can do the same with any Android application that it is out there. Of course, I'm doing this with something that I wrote, so there's no issues whatsoever. So once we're actually getting to see a little bit better, let's start discovering what actually got decompiled. So I'm going to start with something that most Android developers will find known, which is the Android manifest file. And again, as you can see in here, we can find pretty much the exact Android manifest file that was written by the developer. We can see that this application has two activities. This activity is the launcher activity, and then we have a second activity. So again, everything aligns with what I just showed you on the demo before. Now let's keep going. I will start with the Kotlin folder, and as you might imagine, I used Kotlin for this application. So Kotlin, of course, got bundled into the whole application. it's not something that we're interested. I'm gonna continue with the original folder, which is a non-readable Android manifest file, so we're not interested in that. There is another metadata folder, which again, we're not interested. So we're moving forward and we're going into resources. And this is where it actually gets a little bit more interesting. In resources, we are having some more known folders like color, for example. In color, again, you can see that there are plenty of Android-generated colors. Again, that is expected, but if I had any custom colors, they would also appear here as simple XML files. Let's move on forward into drawables. So you saw that the application that I was using had a single drawable, so let's try to find that. So if I scroll down, there's a single PNG image, and this is it. This is the full resolution image that I used when I developed the application, straight there. So any images that you might have had in your applications, again, they're right here. Somebody can obtain them, change them, and put them and create a new application and put them back up into the wild. Let us move further down. Let's go into layouts, because on the layout folder, we might be able to see why we cannot see the second line of text in the application. Again, plenty of Android-generated layouts. We can't avoid all of this, but if we try to find some more user-generated ones, we will see the activity_main, which again, it might ring some bells. And in here, again, we are seeing an image view, two text views, and a button, which is the first screen. The two texts, like the first text view gets their value from the strings, and the second text view is just hard-coded. So again, anything hard-coded, as you can see, is right there in plain sight for everyone. Now, activity secret might be more interested. And as well, we can see two text views, so it aligns with what we knew before. The first text view is exactly says below is my secret key, and then there's another one. Now, the value for this text is, this is a placeholder for my hidden message, so we guess that this is not exactly what the developer wanted us to find. But let's see why we could not see it. And if we scroll to the left, we will see that the text color was white on white background. So a simpler way would be to just open like a dark theme, so it would be white text on black background, just to see the text. But on this specific occasion, this is why we could not see it. Now, let's continue digging further to see if we can actually find out what was written in there. Now, let's open the values folder. Again, values folder might ring a little bells for Android developers, and we're going to have dimensions, we're going to have troubles, but the most important one is strings. And why I am talking too much about strings is because I've seen in quite a lot of occasions, a lot of developers are storing in there any important keys that they might need. So keys for, like if you have an AWS account or if you have any type of service that needs your key. I've seen, it's quite common for people that are not aware of this whole situation to just store their key on strings. So it's easily usable when you're developing. But then again, when you're doing this thing and your application goes live, anybody can just decompile, get anything from strings, and then use it to actually abuse it instead of using it. They can abuse it to do whatever they want. So what I'm trying to say is use strings wisely. If there's something that you don't care, like it's not sensitive, you don't care if it falls into anybody's hands, you don't care if somebody learns about it, then feel free to use strings. It's really valuable tool. You can use translations, you can use plenty of stuff, but don't put anything sensitive in there. All right, now I will close this folder and we will go and open a Smalley folder. Again, so a little bit of background information. Smalley is some sort of like middle ground decompiling for bytecode. It can show a little bit of stuff, but not everything. So I'm just going to go through that really quick, and then we're actually going to try to get to the actual Java files. So on the Smalley folder, again, we have Android folders, we have Android X folders. All of these are bundled with the Android OS. But if we go further, we will see that we actually have the package that we created, and this is the super secret application. And in there, we will see that we have a constants.smalley, which might be interested. We have a main activity, which also might be interesting. And we have a secret activity, which might be interesting as well. So I'm just going to open constants because I don't want to go into further details as to how small files work, but just by opening constants and just browsing through it, we will see that there is something called D2, and there is something that's called access key, which again, if you snoop around, it might be useful. There is something called AWS secret key, which also might be useful. There is something else called encryption key. So again, we will see that there are some things that it would be really good to find out. So let's go further down. Gibberish that some people might not understand, but we can just focus on strings here. So there is one string there, there's a second string here, and then a third string right there. Again, we don't know which is which, so we will continue digging through in order to find out. And now, let's go into the actual Java. Oh, this is not the proper folder maybe. Let's go in here. The Java did not, of course, the Java did not get decompiled. Let us go. Let's go to desktop again and decompile it one more time. APK file and decompile Java, please. Let's try one more time. Okay. And now, yes, now we have Java source. Cool. So please open that up. All right. Sorry for that. Thank you for waiting. Now we have a Java source folder. This is what actually I was trying to get at the end. Now let's actually get to look the Java source file, and this is the actual Java or Kotlin that I wrote that got converted to Java, and this is what we want to find out. Again, Android and Android X folders, we don't really care about them. Kotlin folders, we don't really care about them. The com folder, again, is for Android. A lot of things are getting bundled within your source code to create an Android application, but of course, the thing that we're mostly interested is our own code. So let's open constants. In constants, it is much more, easily readable than what we did before, and we see that the encryption key is 1, 2, 3, 4, 5, 6, blah, blah, blah. This is the AWS key, and this is the AWS secret key. So again, the reason that I'm having this file over here is because I want to stress again, if you have any sensitive keys that you don't want anybody to find out, please don't hard code them into the application. I know that it feels that I'm not giving you many options. I do understand that. I've been there. It's not an easy thing to actually hide something properly because an Android application is open and it is just available to anyone. So anyone can have all the time in the world to decompile and do whatever they want. I know it feels pretty bad, but I'm going to show you a little bit, some tips and tricks on how to make it a little bit better. But again, if you hard code something into Java or Kotlin, it's going to be right there. Now, we will see the main activity, which is nothing too important. Let me close that thing. And we're having a button, which on-click listener pretty much calls this method and starts the second activity, as we saw in the demo. We have an encryption method, which is not actually encryption because it just reverses a string. So you can see that anything that was written, even in just like Kotlin X, it's just right there for everybody to just understand. And now if we open the secret activity, we will see that we're having a single text view and we're setting the text value to the AWS secret key. So the AWS secret key value is that one, and this is what was written into the demo application before. So the reason I'm doing all of that is just I want to raise awareness. I want to show you that an Android application is nothing but a glorified zip file. It literally is just all of the source code and all of the resources bundled and zipped into a file that got renamed into APK. It doesn't provide any sort of security at this point, so it is up to us to try to hide as many things as possible. Now, I will continue with the talk, and I will go to the middle and continue with the defense. So, in that part, I will actually take you through various occasions. I will start with more specific ones, like, if your application checks for location, for example, and I will move further into the more generic ones that, it applies to as many Android applications as possible. And I'm going to show you what you can do as developers to pretty much either hide or check for any attacker that might be trying to abuse this way. So beginning for when you're building an application that checks for GPS positioning, please always check for mock locations. Mock locations is the simplest thing that's been used by literally free apps everywhere. Like, you can get free apps to do whatever you want, and it is as simple as a small if statement inside your application to just check if mock locationing is enabled, and then act accordingly. Do whatever you want, either display a message or cut off the user, or do whatever you might feel is best. Now, second thing, what happens if your application communicates with the internet, which again is much more usual. So what I want to say is that we always need to act based on every single HTTP response. What do I mean with that? So I've done it quite a lot of times, is when I'm making an HTTP request. On the response part, I'm using something like, if the response is the expected one, the correct one, do work, else either do nothing or show a message or not do something that's actually useful in terms of security. But what happens if this else statement is because it was a 404 or a 500 or an user not authorized? So what I mean is that we should always be checking what was the error in your HTTP responses and then act accordingly. If, for example, is user unauthorized, it's probably because somebody found out your API and it's just trying to spam it without either the correct headers, the correct user headers, or an old user header. So when something like this happened, you always need to act based on that information. Again, what you're going to do when you act is up to you. You can either display messages, you can either sign off the user, you can either stop the progress of the workflow of your application, you can even go in more extreme steps and just cut off this MAC address that's doing this request. It's up to you to act based on that, but you always should just watch for it. You always should make sure that you are aware of everything. Awesome. Now, local storage. Again, plenty of Android applications are actually storing stuff on the device. So what happens? What types of data are we storing and where? So we will begin with the worst place to store data, which is the shared preferences and the external storage. And why this is the worst? It is, again, because all of the data there are just stored in plain text, unencrypted. So again, if you store something there, it's up to anybody to just go into their device. Again, no need to have any sort of hacking or development knowledge. There are literally free applications that are doing this for you. And they can go into their device, check out what's happening on the search preferences, read, and most importantly, tweak, change, or delete anything that they might want. So when should we use search preferences and external storage? Again, I'm not telling you don't use them. I'm telling you use them wisely. You should be using them when you want to store something that, again, you don't care if it's found out, you don't care if it's tweaked. So again, as an example, if I am storing some plain settings, I have a weather application and the user decides if they want to show the weather in Celsius or Fahrenheit. This is a simple thing. I don't care if somebody goes to all the trouble to change the default selection from Celsius to Fahrenheit or something else. Or if the user prefers to have the time on a 12-hour or 24-hour format. I don't really care about these things. So I'm just going to do the simplest thing and I'm going to use search preferences. But if I have something more important, again, I'm cycling back to any key, any service key that you might be using. Those are usually the most sensitive and the most important things that are living within your application. Again, do not use search preferences. Although, as I said before, I'm going to tell you a couple of places that you can actually store some sensitive information, and the next is one of them. So you can use encrypted search preferences to store some of your sensitive information. So encrypted shared preferences is exactly as the name suggests, is a form of shared preferences, but everything is just encrypted by the Android operating system. It's not up to the user to provide the keys. The user is just like the user and the developer are just getting an abstract encryption layer that they can use above shared preferences to, make anything better. And how encrypted shared preferences work? They work using the key store. Key store, again, is a feature that comes bundled with Android, with the Android operating system. And of course, over there, all of the encryption keys are stored. All of the material that are highly confidential are right there. And pretty much Google tells us that, hey, you can store things here and we will take care of how we will hide it. It's an abstract layer to the developer. We do like abstract layers. And key store and encrypted shared preferences are definitely a good place that you can store anything that might be even remotely sensitive for your Android application. Awesome. Now, moving on, NDK. As you know, you can write an Android application in Java or Kotlin, but there is always, of course, the option to go fully native and write some Android code in C or C++. Now, why would you do that? It is much more complicated. It's definitely not convenient. So why? Why would you use the NDK? So the NDK is still source code, it's still bytecode. It still can be decompiled. It still can be found out, but it's just a little bit more hard for people to find out what's happening there. So if you have a key, if you have an important key that you have to hard code in your application and there is no way to obtain it any other way, then it's better to just use the NDK, store it in there. Even better, instead of just hard code it, make an algorithm that actually creates the key for you. That would be the best thing to do. Store it in there, and you're just adding an extra step of complexity to any attacker that just wants to try to find this thing. All right, we're getting into the last couple of steps. APK signature check. So in the beginning, I spoke about the key. The key is what we're using to sign our applications. And again, the main thing, the most important thing about our key is it is the only thing that stays within our reach. Everything else goes into the hacker's hands, but the key always stays within you. So what can you do? When you're running your application, you can always check what key was used to sign the specific version of the application that's running right now on its user's phone. And if you know your own key, you know the hash of your own key, you know the key that was used to sign the specific version that's running right now, you can always compare, you can always check. If those two keys match, then you're fairly certain that the version of the application that's running right now on the device is the version that you created. If the versions don't match, it is really probable that somebody decompiled the application, tweaked something, and then used their own key to sign it back again. So again, really important step, really great information on how to check those kinds of stuff, how to make sure that all of your user base run the application that you meant for them to run and not a tweaked application. And then last but not least, if you have like an algorithm, something super critical that differentiates you from all of your competition, just don't put it there. You can hide it again into an abstraction layer. You can create an API. You can just put it into your backend. The backend is, again, in your rates. It's not an APK that just goes to everybody. So you have more security, more control over it. So if you have something that can be abstracted in there, it might be a good idea to think of the pros and cons of just putting it over there. Now, before I finish, I want to stress out that everything that we just said relies on a secure operating system. As we know, Android operating system can be rooted and can be tweaked into major depths. So if somebody runs your application into a tweaked device like that, then unfortunately it's not up to us to pretty much all of those checks that I just mentioned before, they can be easily bypassed. The signature check can be bypassed, the location, even without mock locations, can be bypassed. Everything that they just said, it's much easier to be bypassed. So I just want you to make sure that, and always have that in your mind, that all of these ideas are just adding more and more steps to someone, to somebody that wants to decompile and just hack your application in general. Attackers with enough determination, with enough time and financial resources still have high chances of accessing what you intended to write. So what you need to do is always you need to have a threat model and develop your application with all of the remediations necessary to accomplish your goals. So that was me. Thank you very much, and I would have any questions.
When you are using SDK or library in Android, you can easily see the compiled version of that SDK in your source code. And you can easily decompile that code. Even Android said you had that button, and you press that button and you see the compiled code, but obfuscated, obviously. But you can figure out what is the algorithm here. Is there any way without putting this algorithm on the backend side that you hide them or, I don't know, make it secure?
So, first of all, excellent question. So yes, it's actually pretty hard, as I mentioned in the whole talk, to actually be 100% sure that you will hide something, because the whole concept of an Android application, it wasn't built to be hidden. I don't know if that's going to change in the future or not, but pretty much you cannot hide the whole thing, but you should just try to hide like the most sensitive parts. And usually those parts are either strings or some types of algorithms. So if it is about data, so strings or anything else, pretty much, you can do any of those methods that I just said before. Either try to rely more heavily on the NDK, because again, NDK is just an extra step of complexity. So again, you're just trying to make it a little bit harder for somebody. And if you're talking about algorithms, so like, again, an algorithm that can be bound into a backend, again, either try to obfuscate it a little bit more, either try to hide it again in the NDK. There's not like 100% bulletproof solution, do that and you will be safe. So that's why, as I said before, you do need to pretty much have your threat model. A threat model is always really important. What happens if, that gets compromised? How will I proceed after that? So to answer your question, there is no 100% bulletproof method, but there are few things that you should just try to focus on more specific parts of your application. Anything else? Oh, yes, I'm sorry.
Hi, first of all, thanks for your talk.
Thank you.
My question is, you showed us ways to, encrypt or obfuscate certain secret data in our application, like encrypted shared preferences or NDK. And there's also the way of just, protecting it in the backend. My question is, what's the best practice of all of them? Because, in a big application, like for example, Amazon's mobile application, out of millions of hackers in the world, at least one of them will have enough resources and time to actually, decrypt those, NDK keys or anything else. So my question is, what's the best practice? Should we protect our secret keys in our backend as always?
So the answer pretty much goes back to the same thing here. There is no 100% bulletproof best option. But you do need to find what works better, what is the best level for your own application. So what do I mean by that? The best practice in terms of security is hide everything. Like have an empty, like a base application that just runs a web view, right? Then your application has nothing. So hackers can, even if they decompile it, they will not find anything. But if you do that, then you have a really bad application, right? So pretty much you try to find your own balance, find what things are, good enough and they're worth hiding either at the backend or, spending more time thinking about how the encryption, like how you will encrypt and decrypt them, how you will obtain or how you will get your encryption keys. Because, even if you have the most advanced, the 512 bytes encryptions and everything, if the hard key is hard coded into your application, then it doesn't matter. It's all the same. So pretty much it is up to you to find the best level of, the best balance of what you should do for your own application, what works better for what you want to accomplish, and then work with that. There's not just one golden path to, to solution.
Thank you. I have a small second question.
Yeah.
So I do some ethical reverse engineering as a hobby, and I find it really hard to find resources for Somali in general. Like there's the official documentation, of course, but it's too long and too complex. Do you have any recommendations on resources for?
No, I actually just went through the whole documentation just as you, and it's more, on my case, it was more that I created some applications, decompiled them, looked at Somali files, and then just tried to figure a lot of stuff myself. All right, again, thank you so much. It was great for having me, and you're awesome. Thank you.